Okay, good morning. First of all, welcome to EA Technology, everyone. Thanks to everyone for joining us today. I guess it's polite to do some introductions first. So my name's David Harding. I'm Business Development Manager here at EA. And with me, we've got Ramiz Ahmed, who's our Head of Monitoring Services. Originally, it was going to be myself and Andy Stewart doing the webinar today, so apologies if you tuned in just to see Andy. But those of you who've already dealt with Ramiz know we've got an excellent substitute. So what are we going to cover in the webinar today? Well, firstly, I need to point out this is not a highly technical webinar aimed at those with lots of experience with partial discharge. What we're trying to achieve with this is to answer some questions which were regularly asked around the topic of PD. So think of it as an introduction to PD kind of session. The webinar is scheduled for around 40-45 minutes or so. The format we aim to follow is around 25 minutes, I guess, of presentation, leaving around 10-15 minutes or so for a question and answer session, during which Ramiz will endeavour to answer as many questions as we can get through in the time that we have. On that point, the whole aim of this webinar is to answer questions that you guys have around partial discharge detection and monitoring. So please don't be shy with your questions. There really is no such thing as a stupid question. So fire them in and we'll do what we can. The method for answering questions, please, is to use the questions tab on the GoToWebinar taskbar, which you should all see on your screens. And please, if you can enter your questions as we go along through the presentation, and at the end we'll get round to as many of them as we can. So the topics we're going to cover today are up there on the first slide. So first up, what is PD? Next, what are the causes and effects of PD? Then on to what is the threat to your business? And this really is the crucial part of the webinar, really. It's where we hope to answer some of the kind of why should I care type questions around PD and demonstrate why PD testing and monitoring is really a vital part of HV asset maintenance. Lastly, on to detection techniques. Now, I'll take this opportunity to point out this is really not a salesy sort of webinar. We're not here to tell you how amazing EA Technology are. You know that, obviously. But during the detection techniques section, we're going to naturally have some discussion around EA Technology products and services. So forgive us for that. We will try and keep this as unsalesy as possible. Okay, so without further ado, we'll make a start. So first of all, what is PD? So PD, or partial discharge, is an electrical discharge which bridges a small proportion of the insulation between two conducting electrodes. We tend to refer to that, you'll hear it a lot through EA, as PD activity. So PD activity can occur anywhere within the insulation system where the electrical field strength exceeds the breakdown strength of that section of the insulation material. So it can happen in voids within solid insulation. It can track across the surface of insulation. It can occur within gas bubbles in liquid insulation, so oil-filled transformers, for example. Or it can form around an electrode in the form of corona. So this slide reinforces how we classify PD with the help of some nice diagrams. So internal discharge, you can see where that can occur within voids inside insulation. So a HV cable, for example. Surface discharge, again, this is where the surface tracks across the surface of the insulation. And the last picture there shows corona discharge, which essentially is caused by the ionization of air around a conductor. Mostly this is not an issue, perfectly natural on some outdoor assets, overhead lines, that sort of thing. So mainly it'll be internal and surface discharge we're looking for when, for example, if we're undertaking a PD survey. So if we look a little bit more at internal PD, a term that I'm sure many of you have come across, so we at EA use it a lot, is TEV, or transient earth voltage. So when we turn up to do a survey, or yourselves, if you're using an UltraTEV, for example, checking the assets, what you're looking for is TEV. And remember, this refers to internal PD only. So what is it? Well, when a discharge occurs inside solid insulation, it emits radio waves, and a small proportion of these radio waves will strike nearby earth metalwork, which will induce a current, and that then flows to earth. And it's the passage of this current which causes TEV, or transient earth voltage, and that can be detected using a suitable device. So when you hear someone from EA banging on about TEV, which we do tend to do quite often, this is what we're referring to. So it's a sure sign that PD activity is present. So internal PD, which we've spoken about, produces TEV and radio waves. It can also cause light and heat. So the picture on the left shows an example of some voids within a cross section of a bushing, possibly. Now this could happen during the manufacturing process. It can happen over time as the material degrades. So if we move to the center picture, surface discharge causes sound. So again, when the EA engineer is carrying out a PD survey, or you're using an UltraTEV, when you're looking for surface discharge, you're checking for ultrasonics, sound. And the middle picture there shows some evidence of surface PD activity. The picture on the right shows evidence of PD within a HV termination box. Now, one of the things that PD can produce is ozone gas. Now, ozone gas has a very pungent smell, which people do tend to describe differently. Some say it's like a burning metal type of smell. Other people sense it as a chemically, almost like a chlorine smell. Either way, I guess if you enter a substation and it smells of either of those things, it's probably not a good idea to go inside. So just to summarize the what is PD section of the webinar, when we're looking for TEV, we're looking for internal PD activity within the insulation. On these pictures here, for example, of a CT, you can see where voids have developed in the insulation layer and PD activity has increased. And then back to surface discharge, or ultrasonic discharge. So a couple of pictures there showing the results of some pretty high levels of surface PD. So when we're looking for ultrasonic or surface PD, we're essentially listening for the sound of PD on the insulation surface. Now, PD has quite a unique sound, as I'm sure many of you have heard. It's an irregular crackling sound, quite distinctive from white noise. And severe cases of PD can even be heard without the use of an UltraTEV or headphones, just with a human ear. Again, probably time to leave the substation if you can hear it just with your own ears. Okay, so we'll move on to the second topic now, which is causes of PD. Why does it happen? Well, a few reasons. We'll touch on a few of them. So manufacturing defects, imperfections within the insulation of cables, the terminations, whatever. Poor or incorrect installation, environmental conditions, so the conditions within the substation, design issues, and lastly, and this is not necessarily what causes PD, but it's certainly what can make PD get worse once it develops, and that's a lack of routine checks or monitoring. So we'll just have a little further look at each of those in turn. So starting with manufacturing defects. On the top picture there, there's some rather cheap and nasty separable connectors with an inadequate layer of semiconductor, which has resulted in material degradation and signs of PD activity. And on the bottom picture there, another cross-section picture showing where voids can occur inside the insulation layer during the manufacturing process. So on to poor installation. We've got a couple of examples here, both cable related. So on the top picture there, we can see some cross cores on cold applied termination by the looks of things, where inadequate space has been left between the phases above the crutch, which has resulted in phase-to-phase PD activity. On the bottom picture, we've got heat shrink termination going into a cable box where the earth wires have been pretty carelessly left too close to the high stress area of the termination, which again has resulted in some PD activity. So poor installation is quite a common cause. Environmental conditions. So, it's well known there's a direct link between the condition of the substation and the condition of the switchgear inside. So, obviously basic things, leaking roof, flooding, condensation, even humidity, all these things can be a contributing factor, not just towards PD, but obviously a whole host of other problems inside the substation. Design issues. On the top picture there, one of the things we mentioned earlier was corona discharge, and this picture is an example of how corona can potentially be an issue inside a substation. So you can see there's a very sharp edge there in a high stress area, which caused corona PD. And the products of that, so the ozone, as we mentioned before, but a whole host of other things, nitrous oxides, nitric acid, all sorts of horrible things which will attack the insulation. And that's what's happened in that case. And on the bottom picture, you can see where some insulated bus bars are running through this panel with a very tight air gap, and PD activity has developed around that entry point. You can see on the picture there the physical damage to the insulation. So onto this final part of this section, and probably the most important actually from an asset maintenance point of view, is the importance of making PD detection and monitoring part of the routine maintenance checks of your assets. So here we've got a couple of pictures of what I admit is a pretty extreme example of what failure can look like. I'm not trying to scare everyone to death, we promise, but there really is an important message here in that PD activity is a real genuine indicator of asset health and should absolutely not be ignored. As it says there, remember, PD activity will never get better, it will only ever get worse. So on to probably the most important part of the presentation, which is what is the threat to your business, why you're here today watching this, and you need to find out, why should I care? That's the kind of question we're trying to answer here. So the first one we're going to look at is asset performance. So we know that PD is the primary cause of faults on medium voltage and high voltage switchgear. How do we know that? Well, according to the Energy Network Association's NEDAS database, which I'm sure many of you are familiar with, around half of all faults on 11 kV switchgear are associated with PD-related insulation failure. And worse than that, 80% or 8 out of 10 of all disruptive failures, so that's failures that resulted in outages, are associated with PD-related insulation failure. So hopefully that gives you some idea of how important this topic really is. Financial loss. Continuing with the what is a threat to your business slides. Well, the second point, financial loss. Any commercial-minded people on the call have suddenly woken up with that phrase, I guess. But anybody who's ever had to order, for example, a new 11 kV package substation after a big failure will know that the lead times on these kind of components are not good. So having to wait 6, 8, 12 weeks, whatever, is simply not an option for most of us. So anything that can avoid the failure in the first place has got to be a good option. Production downtime. Now, this obviously means different things to different people. If you're a network operator, for example, you don't want to lose power, as it will mean customer minutes lost, and hefty fines from Ofgem. If you're an industrial enterprise producing some kind of manufactured goods, you lose power, you lose production. You lose production, you lose money. If you're a rail operator, a hospital, sports stadium, any of these things, ultimately can't afford to be without power. So essentially the aim of PD monitoring is to avoid these costly outages, avoid disruptions to the customer, and to keep people safe. And that point actually leads me on nicely to the final slide in this section, health and safety. So obviously the health, safety and well-being of employees is the primary concern of any employer, or certainly should be. The before and after pictures on this slide demonstrate the pretty devastating results of a catastrophic failure in a substation, and there's a reminder for everyone of the potential for things to go pretty badly wrong. So even the most rudimentary first pass procedure when entering a substation can avoid any risk to the well-being of personnel. Now, this may mean using an UltraTev on entering the substation as an initial first pass, is it safe to come in here kind of procedure. But even thinking back to, competent person training, use your senses to determine if everything appears to be okay to enter. At the end of the day, we all want to come home from work safely. So on to detection methods. What we need to discuss in this section is the methods that are available for detecting, measuring and monitoring PD activity. Now, as I mentioned at the start, this is not in any way intended to be a salesy sort of webinar. However, obviously we have to run through the products that we at EA have available and give a kind of high level overview of what they do and how they're used. So we're going to concentrate on 3 products. There are more, but we're going to concentrate on the UltraTev detector, which is shown on the left-hand side there. Then the UltraTev Plus 2, which is pictured in the middle, and lastly the Astute HV monitoring system. Now, essentially, all begin with the basic principle of detecting PD, but all have different levels of capability when it comes to measuring, monitoring, and reporting on PD activity. So we'll have a little look at the UltraTev detector first. Now, basically, as I said, this is a first pass type of instrument, which essentially tells the user if there is PD activity present. Now, it does this using inbuilt threshold levels and utilizes a traffic light system on the display. Pretty basic. So green means no PD activity detected. Amber is low level PD activity detected, so no immediate major issues, but further investigation is needed. And red basically means significant or high levels of PD has been detected, in which case it's probably time to leave the area and some urgent further investigation will be needed. Great thing about the detector is it gives an instant snapshot of the levels of PD activity. It really is very simple to use. Even I can use this one. And it does detect both TEV, so internal PD, and ultrasonic surface PD. It comes with a headset for when you're listening for ultrasonics. That really is the detector in a nutshell. It's pretty straightforward, but highly effective as a first pass level of PD detection. So onto the UltraTev Plus 2. Now this is the kind of next level instrument up from the detector. Obviously you've got the capability of looking for TEV and ultrasonics, but this time you get an actual level, an actual real-time display of the levels of PD. It also gives you a phase plot or phase resolved PD pattern, so a visual representation of the PD activity. It also has the capability to store data, to compare readings over time, essentially. So it uses NFC tags or near field communication tags, which can be used. They're literally just stuck onto the switchgear where the reading was taken, and then in whatever 3-6 months time, whenever the next reading is done, a direct comparison can be made, which is obviously ideal for monitoring developing and growing levels of PD activity. There really is a whole lot more to this instrument, but for the purpose of today's topic, don't want to get too involved in the ins and outs and bogged down in the details. But obviously, anybody wants to know any more on this instrument or any of the topics covered today, then obviously please just get in touch. And then I will hand over to Ramiz, who's going to have a look at the Astute monitoring system for us.
Thanks, Dave. Can you hear me okay?
Yeah.
Right. Okay. So I'm just going to talk about the sort of the continuous monitoring side of things. So you've seen the first the AutoTep detector, which is an entry level traffic light system instrument that allows you to do a quick first pass when you're entering a substation or doing switching. You can go a level up with the AutoTep Plus instrument, where you can do a little bit more detailed analysis when you are within the substation, doing a little bit more detailed analysis of the partial discharge activity that you might pick up. If you've gone through a large asset base, then you will come to a situation where you've identified some PD on some of your critical assets, and for whatever reason, whether that's operational reason or budgetary reason, that you can't do any remedial actions, you would want to monitor that partial discharge activity and to see and trend it if it's going to increase over time. And that's where continuous monitoring, or as we call it, the astute HV monitoring comes into play. It essentially is a 24/7 monitoring system. It's a modular system, so it allows you to install individual nodes and individual sensors around the switchgear, around the different components of the switchgear as well, and as well as cables as well. As just like with all the other PD equipment, it's a non-intrusive equipment, so you don't really need to have an outage to install any of this equipment. So you can install the AutoTep monitor system while the equipment is still in service. Because it is a clever system, what it allows you to do is it captures the data, and you can set different types of alarms, and you can actually send those alarms to via email or text messages to whoever the nominated people are, and that uses 3G, 4G communication to feed the data back to cloud. And because it can monitor multiple panels, you can actually get a holistic picture of your whole switchgear board or cable assets as well. So it allows you to monitor the activity and trend the activity, and you can see how if there's any partial discharge activity, how it's progressing across different components. Next slide, please, Dave. Could you just move to the next slide, please, Dave?
Yep, sorry, go on.
Right, so, and what are the benefits? Again, it provides you with enough warning of partial discharge activity that you can plan any remedial maintenance into your normal operations, and it avoids lost productivity. Of course, because you're not letting partial discharge activity get so worse that it'll cause permanent damage to your equipment, so it saves you on costs of replacement components. And because you're actually preempting the repairs or monitoring, you're doing proactive repairs rather than reactive repairs, it saves you on costs of unplanned labor as well. There are, again, because you are preventing any outages, it reduces the risk of CI and CML fines as well, and it improves the availability of your asset, maximizes the availability of your assets, and improves the lifespan of your asset as well. And because it's cheap enough, you can actually get a very quick payback period on the monitoring services. And the idea with the astute monitoring service is that instead of you nominating specific engineers within the company looking at the data 24/7 or whenever the alarms occur, you can actually get PD experts like EA's Technology to look at those assets for you, and then we can actually look at the alarms, and we can make the first pass and make the judgment whether the activity that we're picking up is genuine partial discharge activity or whether it's just external noise that we're picking up. So you can actually focus on your day jobs while we look at the partial discharge activity for you, and you can make informed operational decisions based on what data we feed back to you guys. And that's it, really.
Brilliant. Thanks, Ruiz. I just following on from that again, any further questions, obviously, please feel free to get in touch on the products and services. We can answer those separately. But obviously today we wanted to look at your questions around PD, really. So I can see some questions have been coming in during the presentation. Have you got sight of those, Ramiz?
Yes, I have. So I think the first one was from Kurt. I think one of the attendees was having some issues with the sound on the PC. I hope they got it resolved. The first question is, what does PD smells of? Surface PD or ultrasonic PD, when it starts to initiate, it usually manifests itself as ultrasonic noise. But if it gets bad enough, it will cause ozone, generation of ozone. That ozone really typically smells like chlorine or bleach. It's a very sharp smell. So if you are entering a substation, a new substation that you haven't been to before, and you smell this very sharp smell, that is typically an indicator that you've got partial discharge activity within the switchgear. So you need to be very careful. If it's bad enough, then you need to obviously carry out the risk assessment of whether you should be within the substation or not, and whatever operation you need to do, just be careful with it. In terms of examples of design issues causing PD, typically this is where a manufacturer changes the insulating material, for example. So say, for example, a ceramic or porcelain insulating material has now been changed with a polymeric insulating material. Both materials, they have different electrical breakdown strength, and they will react differently to electrical stress, and that's where it starts to cause partial discharge activity, typically surface PD, but it can lead to internal PD as well. Other examples include where they've changed the design, where they've introduced sharp edges within the high electrical stress areas, and that then again causes partial discharge activity.
We've got one here, Ramiz. How can the Astute HV monitoring system be installed onto an 11 kV oil-filled transformer?
Yes, you can. We can install the Astute HV monitoring system. It covers a lot of the electrical assets, so oil-filled transformers is not a problem. You can install ultrasonic sensors. You can install TEP sensors onto them as well. So yes, you can monitor 11 kV oil-filled transformers. What noise filtering techniques we normally use for monitoring systems? So we have built-in algorithms that look at different types of partial discharge activity. So it looks at noise filtration using artificial intelligence. There's also actual hardware noise cancelling as well. So what we normally do is we install some antennas around the monitoring system. So we can actually pick up any external interference using those antennas, so we can actually differentiate between noise that is being imported outside the switchgear or something that's being generated, partial discharge activity that's being generated within the switchgear. So we can actually differentiate between noise and PD activity. There was one more question. So there was a question about ultra-TEV activity or PD activity on cable terminations. You can actually detect PD activity on the cables or the cable terminations just by using the, say, for example, the ultra-TEV +2 instrument. Not typically, when you're looking for cable PD, you use a high frequency current transformer, HFCT. You clip it around the earth to capture the PD. With that, you're looking at the PD along the length of the cable. But if you were just looking at the cable termination box or just the first 5 to 10 meters, what you can do is you can just place the instrument onto the cable insulation itself if you have got access to the cable, and that will actually pick up any PD activity that's on the cable terminations or the first 5 to 10 meters of the cable itself. In a typical HV substation, you normally have a transition joint just outside the substation building, and then the last 5 to 10 meters are within the substation itself. So those 5 to 10 meters, you can actually use the +2 instrument, and just by placing the instrument onto the cable itself, you can actually pick up PD activity that way. Right. Is there any more questions?
There's a couple more here. One which I can answer, I think. Do you offer on-site training for use in the UltraTEV Plus? Yes, we do. Just get in touch after the webinar, and we can sort something out for you there. Next one here. Does background noise affect the operation and results of the device? I guess this refers to the UltraTEV Plus 2.
It does. There are some instances where, especially, so say if you are in a grid site, for example, you have overhead, you have extra high voltage equipment outdoors. You have You might have overhead line infrastructure outside as well, and that can generate corona and external noise as well. So it can get affected by the noise. But what you can do is you can actually, with the UltraTEF Plus instrument, for example, it locks onto the phase frequency. So when you are within the substation, you actually look at the phase plot, and that quite quickly allows you to differentiate between whether what you're picking up is external noise or whether it's actually genuine PD. So there are built-in features within the instrument that allows you to actually differentiate between noise, background noise, or partial discharge activity. A lot of the times, if you're in a substation, for example, the overhead lights, for example, they can cause partial discharge activity, especially the older types of lights. So it's a case of just switching the lights off while you're doing the survey. Of course, make sure that you have adequate lighting available, head torch or something, so that you know exactly where you're going and not putting yourself into danger. But you can switch the lights off and then eliminate that noise source and carry out a partial discharge survey.
Well, thanks, Ramiz. Another one I can see, does LV Systems provide TEV or PD? I'm guessing the answer to that is no, but I'll pass over to Ramiz to elaborate on that.
So PD obviously is voltage related. So the higher the voltage, the more chances of you detecting and carrying and finding partial discharge activity. So LV systems generally generate so much noise that and there is so low electrical stress that you don't normally find any PD activity in LV systems. But there are other methods of finding issues with your LV equipment, whether that's LV cable monitoring equipment or thermographic surveys. There's other ways that you can find out any issues with the LV equipment.
Perfect, thanks. There's one here regarding Astute. So does the new Astute system now indicate where issues are compared to the older systems which alarm but did not highlight where the trigger came from?
It does. Because you have multiple sensors across the switchboard, then you can actually identify which sensor picked up the PD activity first. So you can look at time of flight between the activity, and you can actually indicate which part of the switchgear the activity started off, and you can locate the activity that way. So yes, it does.
Okay. There's one here. I have a company, I won't mention the company name, which carries out surveys once every 12 months. Is this enough? It's a bit loaded question, that one, I guess, but
there's multiple factors in there. So routine testing, 12 months is more than enough to carry out routine testing. If you do find any assets which have got partial discharge activity, we would recommend that you do a bit more frequent partial discharge testing on those assets. So what we normally do is in the UltraTEF Plus 2, we have the 3 different bands of PD activity. The green band goes from 0 to 19 dB, and what that indicates is there may be some low-level partial discharge activity. You should just continue doing routine service, and that could be 12 months. Anything between 20 and 29, it's in the amber range. What that means is that activity is there and it's starting to cause the damage now. And what you should be doing is a bit more frequent PD service, so you can trend whether the activity is increasing, and then you can do some remedial actions. Anything 30 dB above, we normally class that as a red category. What that means is the damage is severe enough that could lead to a catastrophic failure, and you need to plan in an immediate remedial action. Typically, if the things are bad enough and the activity is 30 dB or above, you need to be very careful when you are within the substation as well. DNOs or industrial customers normally put in restrictions on entry to the substations if they can't do any outages. But you might want to install some monitoring system there as well to make sure that any activity that you are picking up is not increasing or how it's trending. So you can employ different methods in managing that partial discharge activity.
Well, thanks, Ramiz. Great question, actually, from Joseph Welsh. How do you gauge when PD activity becomes severe enough that remedial action is needed?
I think I just answered that question, didn't I? So one way is obviously looking at what level of activity that is it that you're picking up, how critical the asset is to you, to the asset owner. So if you can live with some PD activity while you plan in some maintenance activity, then you can install some monitoring system and you can monitor it. But typically anything 30 dB or above, we normally say you need to plan in any remedial actions as soon as possible. And if you can't do any remedial actions, at least investigate the source of the activity, whether that's internal PD or whether that's surface PD, so that you can actually plan in what remedial actions you need to take.
Brill. There's a couple more, I think. How much interference does inverter-based generation cause on the Ultratev units, and what can be done to mitigate this?
Unfortunately, yes. Inverters do cause a lot of problems, especially in wind turbines, for example. Because of or solar farms, the inverters can cause quite a lot of noise, background noise that can affect any partial discharge surveys. Typically, what we recommend is to carry out a survey when the inverters are switched off. If you are on site and if you can switch them off, then do a survey that way. And obviously, it's not always possible because of operational reasons, whatever. The Ultratev Plus 2 again has the phase reference, so you can actually look at the phase plot and you can make an informed judgment whether the activity that you're picking up, whether that's being caused by the inverters or it is genuine partial discharge activity. So there are a few features available on the instrument that allow you to mitigate the effects of inverter noise.
Thanks, Maurice. One more here. I've known attempts to clean up PD damage. Is it safe to say that this really is a futile solution and that only replacement of components that have discharged is the only certain way of resolving PD and further risk?
That's a good question. I suppose it depends on the extent of the damage. Sometimes surface PD, cleaning the effects of PD and making sure whatever the root cause of the PD was, whether that was phase cables being too close or improving the environmental conditions, that will help in reducing any future effects of PD. Unfortunately, surface PD, once it starts, unless you do something about it, it's not going to go away. So if you were to leave it as it is, it will continue to cause damage until it leads to a failure. So I think jumping to a straight component replacement might be a very expensive thing for asset owners. So cleaning can help, but it depends on the extent of damage that's been caused by the partial discharge activity.
Real, thanks. Just got time for one more, I think. I think this is Ultratev related. Is the instrument suitable for outdoor PD activity, solar farms, for example?
It is. It is. So you can actually use Ultratev Plus 2 outdoors and outdoor switchgear as well. Again, the issue with the inverter noise does come in, but there are some features on the instrument that allow you to differentiate between noise or genuine partial discharge activity.
Brill, thanks, Ramesh. We're running a little short on time now. Thanks for your questions, guys. There's actually more there we haven't got around to, but what we'll follow up on the back of this and we'll answer any questions that you had. There's also a couple of price inquiries come in there for Astute, which is very kind of you. We can't answer those now, but if you wouldn't mind, obviously I'll follow it up with you, but send your inquiries in and we're obviously happy to organise a quotation for you for an Astute system. So that's pretty much it, guys. Thank you very much for your time. We hope we got around to answering most of your questions. Like I say, anyone's we'll follow up on and answer after the webinar. So thanks again. Hopefully see you again soon, and take care. Bye-bye.
Thank you.